In this video, we're going to be taking a look at one other type of visual representation we can use to aid us in solving probability questions. Let's go ahead and get right into it. So what we're going to be looking at today is a sample space diagram. It's a useful way to represent the whole sample space and often takes the form of a table, usually a grid. Now, let's say, for instance, that we have a red and blue dice that are rolled together, and we want to calculate some different probabilities. So I have red going from left to right, and I could roll a 1, a 2, a 3, a 4, a 5, and a 6 on that. And then I'll have blue going up and down, and I could have 1, 2, 3, 4, 5, and 6. So now let's take a look at what the what the different outcomes might be. So it's a little bit tedious, but this could be a 1 and a 1. This right here could be a 2 and a 1, or a 3 and a 1, or a 4 and a 1, or a 5 and a 1, and a 6 and a 1. Then I would have a 1, then I have a 1 and a 2 and a 2, a 3 and a 2, a 4 and a 2, a 5 and a 2, then a 6 and a 2. So you can already kind of see some patterns develop. That my second number here, because I'm considering that to be red, would be 3, 3, 3, 3, 3, 3, and then 1, 2, 3, 4, 5, and 6. You can also go from left to right. That this would all be 5, this would all be 5, this would all be 4, this would all be 3. Whatever helps you do this quickest, that's the way I recommend it. So go ahead and I'll have my editor skip through this. Let's go ahead and think about what is the probability of the total score being 7. So how can I get 7 is really the question. Well, I could have a 6 and a, oh, that's the eraser. Well, I could have a 6 and a 1 or a 1 and a 6. So that's going to be 2. So I'll keep a tally. I have 1, 2. What else could I have? I could have a 2 and a 5. Well, I have a 2 and a 5 here. And I have a 5 and a 2 here. That's going to be another 2. Another way to get that would be a 4 and a 3. So I have a 4 and a 3 right here, and then a 4 and a 3 right there. So that's going to be 1, 2. And that will basically take up all of the possibilities. So I'd have 1, 2, 3, 4, 5, and 6, which means that I have 6 out of how many totals? Well, you could count up all these squares, 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6 to give me a total of 36 squares. Give me a probability of 1 out of 6 to give me a total score of 7. So how about the same number that comes up for both die? The same number that comes up. So I'll have 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, and 6 and 6. Again, that's 6 out of 36. That's 1 out of 6. The difference between the scores is 1. So basically, I would have 1 and 2. So again, it kind of depends if you want to define it as -1. I'm not. I'm just going to be like, hey, any difference, absolute value kind of thing is 1. So I'd have 1 and 2, 3 and 4, 5 and 6, 7 and 8, 9 and 10. That's going to give me 10 out of 36. Again, depends if you need to simplify. Depends if you want to divide it into your calculator and get an answer. D would be the score that on the red dice is less than the score on the blue dice. So remember that I said that my red is this second number. So the probability that the red dice is less than the score on the blue dice. So I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I would have 15 out of 36. And then E would be that the total score is a prime number, meaning that my sum is going to be a prime number. So 1 plus 1 is 2. That's a prime number. So I'm going to have 1 right here. 3 is a prime number. So right there and right there. 3 and 1 is 4. No. 4. No. And I have 5. So 5, 5, and 5. Then I have 6, 6, 6, and 6. Oh, I have another 5 right here. So that wouldn't work. Okay, right. And then 7 would work. So I'd have 7, 7, 7, 7, 7, and 7. 8 wouldn't work. 9 wouldn't work. 10 wouldn't work. 11 would work. And there we go. So I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Again, 15 out of 36. So you can make these a little bit complicated, but as long as you remember the fundamentals on what the probability means, you can go ahead and use a space diagram to help you solve those equations. So let's take a look at another one. So let's take a look at a problem where you have to create our own table again. So what we're doing in this experiment is we're tossing a coin and then rolling a dice. So now let's make a sample space diagram for this experiment in particular. So find the probability that in a single experiment you obtain a head and a number less than 3 on the dice. So what we're going to do is, just like our last time, is we're going to put those probabilities together, put those outcomes together, and see how likely they are to occur. So here I'm going to get a heads and a 1 and a tails and a 1, heads and a 2, tails and a 2, heads and a 3, tails and a 3, heads and a 4, tails and a 4, heads and a 5, tails and a 5, heads and a 6, tails and a 6. So now, how many total do I have? Well, I have 2 and 6, so I have 12 total squares. Now let's find the probability that in a single experiment I obtain a head and a number less than 3. It has to be less than 3, so I have 1 and 2, and that's actually it, because once I get to here, I now have numbers greater than 3, and anything on this column is going to have tails. So I'm only going to have 1 and 2 out of my 12, which would give me a probability of 1/6. So that's what sample space diagrams are, a nice visual way for us to easily count up probabilities, although they are kind of a pain to make. But if you get used to them, I promise that they come very quickly. So thanks for watching, and I'll see you all in the next video.